Okay, I'm going to do a video. I assigned this lesson through the Khan Academy, but a few students asked me if I could explain it in a different way. So the lesson's about doing a 2-sample t-test when n is less than 30. Okay, so I'll send you the notes. And if n is more than 30, you use z. But if n is less than 30, you use t. And then if you read in your book, there's 2 ways of doing it. One of them is assuming that your variances are equal, and that's called pooled. And the other way is assuming the variances are not equal, and that would be not pooled. So in real life, we usually don't know the variance. So we're always going to assume for the lesson that they're not equal. And we're going to be using this formula here. Okay, so I'll send a copy of the notes. Assuming the variances are not equal, which is what we're going to do all the time in this chapter. This is the formula that you're going to use. So you get the average of your first list minus the average of the second one. And in the denominator, you have the standard deviation of the first one squared divided by n. And then you add it to the standard deviation of the second data set squared divided by that n. And your degrees of freedom will be get the smaller n and then subtract from 1, whichever is smallest. Obviously, if they're equal, then it won't matter. And then this flow chart is just reminding you that if n is 30 or more, you use z, and if n is less than 30, assuming that it's normal, then that's when you use t, and then that's when you would use this. And like I said, we're always going to assume that variances are not equal, so you can ignore this here. We're never going to use that. It's going to be this. Let me do an example. Okay, so let's say that you want to know if there's a difference in the braking distance in 2 vehicles, the GTI, Volkswagen, and the Ford Focus. So this would be example 1 on page 454, if you want to follow along. So you're going to test the vehicles and you're going to see what the braking distance is. And here's the information. So the average for the GTI was 134 feet, and for the Focus it was 143. And then here's the standard deviations for both and n. So the question is there a difference in the mean braking distance for the 2 types of cars? It gives you alpha, and then it says assume the variances are not equal, which is the way that we're going to do the problems. Okay, so we're going to be using this information to put into this formula. But before we do that, we want to write the hypotheses. Okay, so remember the keywords. So in this problem, the keyword is difference. Is there a difference? And when that's the keyword, we use equals and not equals. If it said, is it higher, lower, then you would use less than or greater than. And then the degrees of freedom is the smaller n. So if we look at the n's, which one's smaller, 8 or 10? 8. So the degrees of freedom will be 8 minus 1, which is 7. The problem says to use a significance level of 0.01. And then from there, we put everything in the formula. So you get all the information. It's given to you. It's here, so you take that, you put it in the formula, and then you use your calculator. You put everything in, and you calculate t. Again, just a reminder, use decimals, because it's easy to input this the same way that you see it on your paper. It'll appear on the calculator. So for t, you get negative 3.49. Because it's t and you don't have a graphing calculator with you, we're going to have to use rejection region. So the way you use a rejection region, just to remind you, is you get your t table and you look at the type of test. Okay, so this would be a 2-tail test. So I go here, 2 tails, and then the significance level is 0.01 and degrees of freedom is 7. So then you go down to the 7 and you get 3.499. So it's almost like 3.5. You can round to 3.5. And that would be right here. So 3.5. And on this side, negative 3.5. because it's a two-tail, so you shade both sides. Then whatever you get for t, that's where you make the dot. So we get negative 3.49, which is very close to what we got. So it's going to be a dot very close to the line, but on the right side. And it's still in the part that's not shaded. It's almost on the shaded part, but it's not. So just a reminder, okay, if it falls on the shaded part, you say you reject. If it falls in the part that's not shaded, you fail to reject. Okay, this one's almost equal, so it could go either way. But negative 3.49 is here. So usually it's not going to be that close, but in this case it could go either way, reject or fail to reject. So either one would be okay. So we're going to go with reject the null, and just the way that you write the sentence is the same as before. So if you reject, you say we have enough evidence to reject the null. Okay, so if you reject the null, you believe the alternative. So we believe that they're not equal. And we conclude that the breaking distances are not equal, or you can say different. It means the same thing. Okay, so all the problems that you'll get are going to be for when the variances are not equal. And it'll be this formula, and then you can just ignore the other one. So hopefully this video helps you in addition to the one that you had seen from the Khan Academy.